try and build the session more. Yeah. I will try and build it something more relevant to the practicing engineer. So how the evaporative cooling can be brought into the mainstream cooling applications, and what kind of savings it can provide, energy savings can provide. So without wasting much time, let's go to the presentation. Let me share my screen first. I will share the entire screen so it is easy for all us to go. Uh, Bhavnaji, you are not mute, so you can tell me.
Yeah.
You can see my screen. Okay, perfect. So this is it. Let me hide this bar and let me go to my presentation. And maybe I will hide your photograph also from my screen so I can make it bigger. Yeah, perfect. So welcome to this session, and thank you for all of you for joining and taking out this niche 40-45 minutes time. And I can promise you that I'll try and bring some value on the table, so you'll find your time is worth well spent. Now, what all we will discuss very quickly, an overview. So, all of you know about evaporative cooling, I'm sure. Very learned audience is sitting among the audiences. What we'll revisit the basic of principle of operation, the different types, their comparison on psychometry, and how the units are configured. I had been a part of different evaporative cooling brands, India and globally. Right now, my company is a European company from Netherlands. So probably, when I talk, you'll find more of a relevant stuff from that particular brand in this whole program, but I'll try and make it more technical and generic. So like unit configuration will be something what we at Oxycom make. Of course, evaporative cooling has its own different combination and configurations. Then we'll spend some time on application with the performance and saving analysis. And that when I say saving analysis, it's hourly where the data being analyzed for the different application. We'll discuss 3 different application as listed there. We'll see the detail once we go inside. There has been a lot of kind of talks going on. I had been to different platforms from where I spoke about evaporative cooling. That's into my blood now. But I will always find water is an issue. So let's look into that, whether really the water is a problem, whether evaporative cooling is something which is a water guzzler, and today's need is both. We have to strike a balance between the water and the energy both. So like in US, there is if you go to the probably let's say the west coast side, you'll find there are legislation which prevents the use of water cooled chillers also. So yes, there is a lot of talks happening in this part of the world, in India, in larger Asian region. But let's look at it, because you will realize at the end of this 2-3 slides that I'll talk there, the water when we use water to provide cooling, as a matter of fact, on a global level and a universal approach, we see we are saving water. How? That we'll see there. Then we'll discuss some application example, and maybe I'll have another presentation if time permits. I'll take it through those slides where some case studies are listed. Most of them are something which we have carried out in Gulf or in Europe. India, it's a start for Oxycom. I had just come on board 4 months back, so it's just a start. We do not have an installation in India, but I can, of course, I had been associated with number of some of the largest installation of evaporative cooling in India as well as in Gulf. I can say 2 of the largest in both these places are something where I was directly connected. So I'll be able to take up some question and answer that. Of course, I'll end it up by talking about my organization as well. So now let's go to the basics of evaporative cooling. Very simple. One of the oldest and the simplest of the cooling technologies. It's invented by Mother Nature, and of course, we human beings have made it perfect to make it usable by the masses. The best part is evaporative cooling. We are dealing with the world's most clean and the natural refrigerant. That's water. It's categorized as R718. Water is an amazing coolant. 1 meter cube, that's 1,000 liters of water, provides cooling equivalent to around 200 tons. And the principle is very clean. You have a hot and dry air coming through, passing through a wet surface where the water is retained. In the process, the air picks up some moisture, its temperature drops down. So that's a kind of an adiabatic process. Means actually, as much as the temperature are dropping, the sensible heat of air that you are removing, you are adding it back into the air in the form of vapor, which is nothing but the latent heat. So the total heat, the enthalpy remains constant, it doesn't change. But what happens? The temperature is lowered, and that gives you the feeling of comfort, and that meets many of our needs where we don't have to resort to more energy guzzler air conditioning solutions. So that's a very simple technology. It doesn't have too many parts. A wet media where the water is sprinkled, water distribution, a small sump, and the tank sort of a thing, and a fan, the prime mover for the air. So that's the only component involved. No compression, no refrigerant, no risk of GHGs, and any other risk associated with the leakage of refrigerant and all. So that's it is. So warm air and water, when they combine, the cooling effect is created, and that's what the evaporative cooling is all about. One small rule, or rather, I should say, I'll put it up to you for your approval. I'm sure people will have questions when we go through the presentation. I will keep it eye on my time. So right now it is 3:22. I will have a hard stop at 3:45, 3:50. So we'll be left with around 10-15 minutes for the question answer. I'll be more than happy to take the any kind of questions which possibly you can answer in 10 to 15 minutes available. Subsequently, also one can connect and ask for questions.
Sure.
You. Now, basics of evaporative cooling, again, continuing with the two different types. One on the left hand side that you see, let me put out a pointer here, a laser pointer, right? So this one is the direct form of evaporative cooling. The word itself suggests everything. It's direct, means air and the water are coming in contact with each other. So water is getting added in the air. So that's the direct evaporative cooling. I explained in the previous slide the same simple function. Hot air comes, it becomes cold and humid air and supplied. Now, technically speaking, as I said earlier, the temperature of the air has reduced. So you can see the temperature has gone down, but the humidity in the air has increased. It has sucked in moisture, and that's how it's absolute as well as relative humidity has gone up. But as much as the temperature energy has reduced, that much of the vapor energy has been added. So the total heat of the air or the enthalpy remains constant. It doesn't change. Whatever the energy was here, whatever the enthalpy was here before it gets into evaporative cooling remains same. So point 1 and point 2 will have same kind of enthalpy. So if you know, sometimes I come across audiences will say, okay, I will use evaporative cooling, take this air and put into my air handling unit. So I am putting low temperature air over the coil and I will have some energy savings. So that's a misnomer, because you have removed the sensible heat, but you added the equal amount of heat in the form of latent energy. So actually, it is not going to do any saving on the tonnage that is required through the cooling coil or chill water coil. So that's where it is an adiabatic process where the heat remains constant. Now, the other form, which is getting a lot of popularity nowadays, it's indirect direct evaporative cooling, very popularly known as two-stage evaporative cooling. I think today I mean, majority of the large users of conventional air washer or evaporative cooling in India are migrating to two-stage evaporative cooling. That's a phenomenal, that's a phenomenon I have witnessed over the past 1.5 decade, you can say, since 2008. Since I am a part of this industry, I have seen that people are migrating from conventional air washer to two-stage for certain benefits. What are those? We will look into the next slide. But broadly speaking, in a two-stage evaporative cooling, what you are doing, first you are cooling the air without adding water, or you can say in an indirect manner. So you have a heat exchanger. It's a water to air heat exchanger. Some people use a air to air heat exchanger also. So different technologies prevail. For the purpose is take the air from outside, reduce its temperature, but in the process don't add water, don't add humidity in the air. So it's a pure sensible cooling. You reduce temperature, keep the grains constant or the absolute humidity constant, and reduce its enthalpy, simply because you've taken out some sensible heat from the air. So its enthalpy has gone down. Now, once you have done this indirect evaporative cooling, the air is now at a lower temperature. Not only dry bulb, but the wet bulb also has reduced. So this can further be cooled by a regular form of evaporative cooling, which is direct type. And then you can get an air as a supply air, which is way below the starting air's temperature, or way below than what this fellow could have done. So you get a lower temperature air, as low as lower than the ambient wet bulb itself. Let's see it on the psychometry to have a clarity. So we do the cooling in two stages, and this air is now air which is at a much lower temperature with less moisture added in the air. This air has a less moisture added. Only in this stage, some amount of moisture is added. Whereas in the direct evaporative cooling, you are adding a lot of air. Just to give an example, it is like outside temperature is 40 plus, and let us assume yourself, you are walking out in the street perspiring, and then you just walk inside a house and you say, I want to drink water, I'm very thirsty. Now you have really come from 44-45 degree temperature, walking half an hour, so you are thirsty. I offer you a glass of water, you will say, give me another one. So probably you'll drink 4 glasses of water to satisfy yourself. Now, if the same scenario, I asked you to come and sit down, and I have a cooler environment than outside, and ask you to wait for 5-10 minutes. Now, your heat level, your stress level, your anxiety level has come down. And then, if I offer you water, you will probably not drink 4 glasses. Two will be enough. So, that is what happens with the air. Moment we take the hot air from outside 40 plus, cool it with the indirect way without adding moisture in a sensible manner, then the air becomes something like 27, 28, or 29. Now, this air, when it is exposed to a wet surface, it will not be able to absorb or hold too much of moisture. So, though the cooling is superior compared to this, the moisture addition which happens only in the second stage is very low. And that gives us a very different edge altogether. So you look normal, a direct evaporative cooling and air conditioning. So probably the two-stage evaporative cooling is a process that supply the air with the quality, thermal quality, which is between these two, superior to direct evaporative cooling. And in terms of thermal comfort, little inferior. It can't reach dew point or break the dew point and reach the dew point. So it will be little less cooler than the air coming from the air conditioner. So that's what the positioning of two-stage evaporative cooling is generally. But yes, with the right selection of application, right explanation, the masses are shifting to go for two-stage evaporative cooling method now. Now, same way, if you compare in this process, when we cool the outdoor air with two stages and bring it out, we have reduced temperature. We have increased humidity, yes, less than this, but still in the second stage, some amount of humidity in the outdoor has been added. But here, since we have done the sensible cooling and reduced the total heat, so overall here from this point 1 to point 3 and 4, what you see here, the enthalpy has come down. So what you have done, essentially, you have taken out some amount of enthalpy from the air, like the air conditioner does. Not to that extent, but yes, similar to the way air conditioner does, removing the heat from the air. So that is the difference between the direct and indirect direct evaporative cooling, or single stage or two-stage evaporative cooling. Let's look at it on the psychometry. So I'm trying to take a real-time condition of average condition of India. Not very hot, of course. In other countries, some Gulf, it will be too high. Europe probably it will not be so much. So trying to localize it and make it for our condition. So let us say the air from outdoor is at 40 degree and its corresponding wet bulb is 24. Now, moment you plot it on psychometry, you will find its absolute humidity, or the total grams of water in the air, is around 13.56. Now you do evaporative cooling in the pure form, which is direct evaporative cooling. The moment you do the direct evaporative cooling, the temperature starts reducing from 40 and go towards 24, and it stops at around 90%. Different manufacturer claim different efficiency, but on an average, it's around 90% reduction will happen. So you get an air which is coming out of the direct evaporative cooler at around 25.6 degrees centigrade. But this is a constant enthalpy line, which is parallel to wet bulb line. So wet bulb doesn't change, it remains same. But by reducing from 40 to 25.6, you have added humidities. From 13.56 grams per kg, it has gone to 19.63. So just to put in right perspective, 14 by 20, so around, you can say 50% of moisture has been added in the air from its original level. Original was 100, now you have made it 150. So that kind of moisture has been added. Let's compare it with two-stage evaporative cooling, which is IDAC. Now, when you do IDAC, initially you are cooling sensibly, which is horizontal line, no moisture adding, but temperature reducing. Then you add moisture and cool it further. So you get eventually the air out at around 21 degrees centigrade, and its wet bulb also shift, just because this line, sensible cooling, is not only reducing the dry bulb temperature, but also the wet bulb temperature. So you have revised wet bulb as around 20.5. The air comes out around 21.2, and the moisture which has been added is only this much, which is from 13.56 gone to 16.1. The gain is you have added from 13.56 to 16.1, as against earlier you were adding so much. So you added 60% less moisture. So the air is not very humid. It's relatively better in terms of moisture level. Good for process, good for people, good for a lot of application. And same time you have done additional cooling of around 5 degrees centigrade. So that's where I'm saying the air from an IDEC unit or two-stage unit is something like going closer to the air conditioning. In fact, in the peak summer time, it is as good as air coming out from the air conditioners. And let us not negate the fact all along both the process, it is 100% fresh outdoor air, no recirculation. Now, this cooling moment you got from direct evaporative cooling or indirect. So, we are talking of these tough conditions of India and average condition. So, you can design a building, let us say at around 30 degrees centigrade. So, the air comes in, picks up some heat of the room, and typically the sensible heat. I am ignoring the latent heat of latent part which it will absorb, because in any case, this air is going to be thrown out, discarded. So, you travel this side and you hit it up in the room condition is stabilized somewhere here. With IDEC, you get a huge delta T. You have so many degrees you can allow it to rise, and you come to the same level. So you see the two conditions. Here the RH is also more, RH is less here. Of course, the absolute humidity also. Now, how does it help in the application? If assume we have an area that we need to cool, we know the heat load of that area. Design of evaporative cooling, you have to ignore latent heat, because in any case the latent heat of the building is thrown out. It's like pushing it out, scrapping it out of the building. So it's not to be counted. Only sensible heat is what matters. So if you're using an IDEC, a two stage, it is cooling 5 degrees centigrade more. That means you can do the cooling for against a particular heat load with the less amount of air. So with IDEC, if you are doing X, with the direct evaporative cooling, you need to provide almost 2 times the air. So you have to put in much more air, double the air to reach the same room temperature. Of course, its absolute humidity is low that we talked about. But what does it mean? It means, first of all, I am putting more, double the air from DAC, which already have a higher level of moisture per kg of air. Almost 3.5 kg grams per kg is more. So when I convert my CFM and all, I will find that with direct evaporative cooling, for maintaining the 30 in the room, I will bring almost 4 times of the moisture in the building compared to what I will do with two stage. So if you do the design, carry out the whole calculation, you will find more CFM with direct evaporative cooling, less with two stage. And the water that will come along with that, because outdoor air, you are adding water in both the processes, less in one, more in other. So with the IDEC, you will add every hour something around 45 liters. And with normal deck, you will be adding around 215 liters of water in the room. You are making the room stuffy and very humid. Although I'm saying direct evaporative cooling has a huge amount of application for certain, select application, it has a very much viability. But the niche application, one should be careful. When you design with IDEC, you have benefit of, if you are maintaining the same room temperature, you will use half the air. Probably you will save both water, the energy, and you will not make the room very stuffy. So these are the benefits you can say the two stage will have over single stage. Now let me move fast, otherwise I think we will miss the timeline. This is how the two stage evaporative cooling works, and this is more respect to what we make in Oxycom. So we use this kind of a configuration. The unit is very compact, low footprint. I'm not trying to advertise my unit here. But it has got two sections. One is the upper portion, which is work air, and the lower portion, which is the process air, or the air that you are going to cool and use in the building. So we have divided the air which is taken from outside into two parts. The upper side, the air is filtered and all, and goes through this adiabatic cooling stage. And in adiabatic, hot air comes, cold air goes out. So it's not only the air is getting cooled, which we in any case we are discarding. We are using this section to cool the water, because in this adiabatic pad are typically the direct evaporative cooling pads. You cool two things, the air as well as the water, both are getting cooled. So now what are you doing? you have this work air fan separate and supply air fan separate. Now look at the lower portion. And the lower portion, we are taking the air from outside, cooling it in a coil type heat exchanger. It's nothing but like a chilled water coil. We are cooling the air in this, bring down some temperature. That's a sensible cooling, and then further cool it in the adiabatic stage, in the second stage, and supply in the building. I am not putting the number here because it varies from different location. But all in all, we are talking about 114 to 115% wet bulb efficiency being achieved in this section. So air from the original level 4024, it will be cooled to the extent of 1.15 times. That much of cooling will happen, and you can get the supplier into the building. I think most of us know how does it work, but let's get into application that I think you will appreciate more. So what are the application? Standalone cooling, use IDEC, two-stage evaporative cooling for cooling the whole building. It can be different application that we'll see. Another application is take this two-stage unit, connect it to a fresh air unit, and reduce the load of the fresh air. Otherwise, this fresh air handling unit would have been taking outdoor and cooling all along. So in a year, it consumes X amount of energy. By adopting this cooling before and feeding it into the FAHU, you are able to save a lot of energy that otherwise would have been wasted. Then another excellent application of normal form, direct evaporative cooling alone, is to do adiabatic cooling of the air-cooled chillers, and that's a very successful application. As far as we in Oxycom are concerned, we had done a lot of data center, we had done a lot of super stores where the air-cooled chillers were installed. We have gone ahead and fixed our cooling pads to make it pre-cooling of air before it go and hit the condenser coil, and that is where the huge amount of energy saving have been achieved. We look at standalone cooling application also. I think very quickly run through. Factories are the one of the very major application, factories and production areas. Then the warehousing, distribution center. Just to give an example, in my career I have also secured and executed a project in Saudi Arabia, which was something, around close to 45,000 square meters, around 5 lakh square feet of warehouse with a height of around 15 to 18 meter, was done totally with two-stage evaporative cooling and with excellent result. And the savings obviously were around 90% in terms of annual energy. And in a place like Saudi Arabia, where probably the water cost is more, the overall economics works out wonderfully well. Then, so distribution center is very good application. Outdoor and semi-outdoor area where air conditioning you can't, because you can't take the, you can't contain the air within the conditioned zone. So every time you have to take the fresh air and cool it. So those areas can be done with two-stage evaporative cooling. Kitchen, atrium lobbies in a large office IT building or big office complex. The atrium lobbies, which are the non-regularly occupied zone. People in the transit, they come, spend little time and move ahead. So those areas can be directly done with this. Utility blocks where why to waste air conditioned air and energy, so much of energy in cooling those areas. Now this will be interesting. I had done the analysis for some major Indian cities. Now how it is, let me just explain it here. Now let's focus on this graph first. It's for New Delhi, a complete 1 year weather data, 365 days, 24 hours. So that means 8,760 hours of analysis. Now this red is the temperature profile of the ambient air. By deploying two-stage evaporative cooling, you are shifting that to this side, towards left, to the lower temperature zone. And this is what the two-stage evaporative cooling deliver against this. This is for an entire year. So mind it, these overlap areas you see mostly will be belonging to the winter time when probably you don't need a cooling. Now, if you only look at summer months, typically from March to June, March, April, May, June, 4 months, you will see the temperature profiles like this. These are the outdoor temperatures, and against that, they can be shifted back to lower temperature range here. So this is the kind of performance possible. Probably don't worry about making a note here. If you need, my email ID will be displayed. You can connect with me, and I can give analysis for any damn place in India for whichever the weather data is officially available on the internet, and probably the DO engines and all. Now same for the entire analysis for different locations. New Delhi, we saw the larger one. This is how the profiler temperature will be in Hyderabad. This will be in Chennai. This is how Ahmedabad will behave. So you see that Delhi, Ahmedabad, typically more of a drier zone. You see a huge shift towards the cooler area. So I mean, a two-stage can cool significantly there. Same is Pune. Pune also is very apt for utilizing in a situation or the weather condition like Pune. This for Bangalore. So this is the temperature shift will happen. Like if you have the outdoor air, if you cool it into a stage, this is the kind of supply temperatures you can expect. Now move on to the next application, which is saving of energy in the pressure handling units, or you can call it as treated fresh air unit. That's a more popular name we use in India. So FAHU or TFAs. So it's the one beauty, now here I'll talk about my units. Oxycom, we have very compact machines, not like big elephant kind of giant machines, 2 BHK, 1 BHK kind of thing. So modular machine. So this can be very easily connected to an existing FAHU. So retrofits very much possible. You don't have to worry about a huge space availability, or the weight is not so big, so much compared to many other two-stage solutions you will find, or only IAC solutions you will find. So it is very ideal for retrofits as well as for the new installation. And compared to many other very complicated animal that the manufacturers and designers have built for treating the outdoor fresh air, they use heat wheel, they use heat pipe, they use runaround coil, they use a lot of features, and then try and make a huge big white elephant. So why to do all this? Have a simple way of doing it. Yes, there can be a little less saving, but then the life cycle costs or paybacks will be much better. So this is a very simple installation, very low maintenance. Only this box need to be additionally added to your existing FAHU. Very ideal for retrofits. Now here, let's look at some saving part. Now the gains are twofold. One is during the peak summer time when the temperatures are maximum, outdoor temperatures are maximum, you take, let us say for this example, 8,000 CFM. Now for 8,000 CFM of pressure handling unit, the without pre-cooling is the blue bar, and with pre-cooling is the orange bar. So like for Ahmedabad, 8,000 CFM would have asked for around 90 plus 90 to 93 kilowatt of power to cool this 8,000 CFM air to a supply temperature around 15 to 16 degrees centigrade. As against that, if we top it up with two-stage evaporative cooling before, treat it there and then put it into this FAHU, this can be brought down to around 74, 75, 75 kilowatts. So that's the kind of 16% is the peak load shaving. We can reduce that much of peak load. Same for different condition, like New Delhi it is 17, Hyderabad 21%, significant. Even in place like Chennai, there is a saving. And it will be interesting to see what is the energy saving annually. That in the next slide we'll cover. Pune is huge, it's around 31%. And Bangalore again, it's good, it's around 29%. So this is the kind of savings in the peak load are possible. It's expressed in kilowatt, that's in the energy, but you can always convert into TRH load and visualize that. Now the same 8,000 CFM AHU, if it is run 24/7 for 8,760 hours, so what kind of annual energy saving it will have? So let's pick up any example. Probably the worst example of Chennai we can pick up. Now for this 8,000 CFM, you have to treat the air and bring it to 14, 15 regularly on an hour after hour basis. Your annual consumption will be something around 300,000 kilowatt hours in a year for doing 8,000 CFM pressure treatment. With pre-cooling, this can be reduced by 8%, and it can be brought to this level of around 260 to 65 thousand kilowatt hours. So this is the kind of 8% saving. The same in case of Pune, it is 30%. In case of Bangalore, it is so much. In case of Ahmedabad, so much. In case of Delhi, it is so much. So this kind of when we are designing the HVAC scheme, when we are doing retrofit, we are doing, as an energy auditor, we will probably be doing some analysis. So this kind of data can help in deciding what is the best way to optimize my HVAC scheme. This application, which is one of the favorite for me, I'm looking at it as a new thing, is very good. So again here, when we do the pre-cooling of air before it goes onto the air-cooled condensers, so there are two ways. One is to save energy, obviously. That's annually we'll see how much we can save. But more important is the peak hour cooling capacity. For example, a chiller which is delivering 100 TR, which is originally designed to deliver 100 TR, over a period of time its performance has reduced. It's a derated, become less, and now you may need to go for a new additional chiller, So you can also explore the option of doing adiabatic pre-cooling and enhancing its capacity back to 100 or little more than 100. So what are those numbers? Let's look at that. And of course, in Oxicom, we make a very nicely tailored solution for different brand of chiller and different configurations with a dedicated pumping station, well enclosed walls of adiabatic cooler. So it's very neat and clean installation. Everything comes well planned from Netherlands, and within half a day or a day we can finish up the whole installation and make a chiller pre-cooled one with adiabatic cooling. Now, how does it work? So just very quickly, let's take train data, performance data. Now you see this is for a unit. Let us look at particular model, whatever is that 155 HELN. Now cooling capacity is as a entering condenser ambient temperature. When it is 30 degree, what it will be, 35, what it will be, so on and so forth, that is given. Let's look at this. When the outdoor is 45, this particular chiller is delivering 431 kilowatt of cooling, and for producing this cooling, it is consuming 204 kilowatt of energy. Just by making the air from 45 by adiabatic cooling, we bring it down to 30. From 431, we have increased its cooling capacity to 538. Moreover, the power consumption, even it's producing more cooling, but the power consumption is reduced to 161. So that's a dual impact. You improve and enhance the cooling capacity, and you need less amount of energy to produce that enhanced capacity as well. So it's a twofold. So in terms of overall EER, we are talking of around 55% enhancement in the EER. So that's significantly high. Now, how does it relate to our conditions? Now, before I go to this, let me talk about peak capacities, how the cooling capacity can increase. Now, this is for a 100-ton chiller. Now, my software directly catches the peak design condition of all these cities and gives me the result. So, for example, in let us say in Ahmedabad, a 100-ton chiller during the peak summer time is going to perform at a level of around 90-94 TR. It is derated. Similar chiller in other condition probably is rated more. In Pune, it is rated to this level. In different condition, different durations have happened. Now, by adopting the pre-cooling before this, putting the adiabatic panels, cooling pads, and then making the air go at lower temperature to the condenser coil, we are increasing the cooling capacity. 20%, 28%, that's quite significant. And it's a very good application for the retrofit cases. Enhance the cooling capacity of existing stock of air-cooled chillers. The old air-cooled chillers can be brought back. They can be, उन्हें दोबारा जान फूंक सकते हैं. So that kind of thing is possible by doing this. Now, what does it relate in terms of annual saving in power, which is also very attractive. So this is what it shows. It's again an analysis for 8760 hour, which can be customized to 12 hour per day, or whatever the timing you suggest. We can punch the timing in software and check it. So it's for New Delhi. We are talking of annual saving of 25%, Ahmedabad 23%, Hyderabad 18%. So like this goes on. Even for place like Chennai, it's a 10% saving in the annual energy consumption of an air cooled chiller. So this is the kind of savings possible by adopting it. So we have another, okay, 5-10 minutes we need to wind up. So I'll move quickly. We have this in this now. This is one of my favorite subject, because as an evaporative cooling man for the last 2 decades, I have been hearing it day in, day out. All my audiences, oh, we don't have water. You imagine I am going and talking to my audiences in Saudi Arabia, and then they say we have water as a big issue here. And then still they are now adopting evaporative cooling in a big way, having understood the truth behind it, the real scene behind it, real life, scenario behind it. Now, as a just putting some facts correctly here, total 77% of the Earth's surface is water. But after, of course, the 77%, hardly 1 or 2% or less than a percent will be available to humankind, because rest is either a seawater or ice. So that's not available for immediate use. That's our water scenario. This I already talked about. So yes, water has got a huge amount of cooling potential. 1 meter cube water gives 695 kilowatt of cooling. But remember, the water cycle is like this. What we have, the water evaporates, goes up into the environment, to the sky, becomes cloud, precipitates, and brings that water back. Now, this is a cycle. The water is not going out of the system. It doesn't go out of the Earth's environment. It remains here and here only. When we say we consume water, use water, don't waste water. So yes, not wasting water means you don't have to incur a cost on treatment of the water and probably spend energy there. But then the water is not lost. It's it's just converted into another form and it can be reclaimed back. So in a way, it's not a water is not going out of the Earth's environmental system. Now look at some of the water consumption when we generate electricity in different kind of power plants. India predominantly we have thermal, so coal is one of our major. Then we have significant amount of nuclear also. So for different kind of generation of electricity, for generating 1 kilowatt of energy, how much liter of water per hour is required? So that is listed here. And rest zero means these are renewables, solar, wind, and all. So now for this, if you take a weighted average, is around 10 liters of water per hour is needed to produce 1 unit of energy. That's also depicted in a pie chart. Now look at this. We know 1 meter cube of water can produce 695 kilowatt of cooling. If this 695 was to be derived from conventional air conditioner, vapor compression based, then you have two parts. One is the fans in that AHUs and all, and the probably air cooled condenser, the condenser fans, and then you have compressor. So producing this kind of cooling 695, which is around 200 tons, you need compressor power and fan power, 78 and 250 kilowatt. Now this 78 kilowatt means at the power plant you are going to consume 780 liters of water. For compressor, you are going to consume around 2,500 liters of water. This plus this is the water consumption for creating a cooling which is only 200 tons, 695 kilowatt. Now this, if you are doing with two-stage evaporative cooling, IDEC cooling, then you have predominantly the consumption is only for the fan and very small power from the pump. So it will be all put together around 3 kilowatt. That means on the power plant, you are going to consume only 30 liters per hour. And at the point where you are using the evaporative cooling, you will consume 1000 liters to produce this cooling. So 1000 plus 30, this is the only water which is needed. Another way of looking at it is this. With evaporative cooling, we are talking of 1030 liters of water for producing 695 kilowatt of cooling. That's 200 tons. And with the conventional air conditioning, eventually you may not be losing it at your home or in your office or in your factory, but somewhere this amount of water is consumed. It makes it very simple, no rocket science behind it. If we have to save water, let's adopt more and more of evaporative cooling. So let's go evaporative to save water. So that's what I wanted to just put across as a thought to all of you. Some application examples. Now we have another. Oh, time is up almost. So what I'll do, I'll just quickly show you some pictures. I have another big set of case studies, which may probably take longer. Yeah.
We can go on. I mean, there's like if you want to complete, you can take some few minutes more.
Okay, I will take thank you, Bhavanaji. I think I'll take another 5-6 minutes, so then I can probably have another 5 minutes for the question answers also. So some examples I'm showing for chiller pre-cooling. So number of places have adopted it in places like UAE, in Europe, of course, ours is European company, so we are doing a lot of work in Europe. So just to tell you about my company very quickly, it's my privilege to share with you. We are Oxycom. We are based in Raalte in Netherlands. It's a town close to Amsterdam, the capital of Netherlands. This is our main product area where we work. You all might have heard about the sustainability development goals. So now out of, I think, total 17 goals or something, we are contributing to almost 6 goals. I'll not dwell into detail of this, which can be a topic for some other day. These are our locations. You will very soon find India is also getting covered with the green color. But these are the places where we operate with our partners, right from North America, complete North America, South America, some select places started. And of course, in Africa, in Europe, complete we are doing. We are also in these other regions and geographies, you can say. Some users of Oxycom product today, so big names. So is getting very well covered from the different spectrum of industry. You may like to take a note of my contact details here, which is this is my email ID and this is my mobile number. So probably have a print screen click. You can click the print screen so you'll save it. And please feel free to connect with me for any kind of questions that we'll have going forward. With the time limits, we will not be able to cover, case study probably. Bhavanaji, would you like to just play one of the videos from your end if you can do that? Hello.
Yeah, I'll do that. You'll have to stop sharing first.
Yeah, I will. Please. 40-50 second video, not more than that. If it is a problem, then we can probably skip it. It's already 4.
Yeah, it's done.
Okay.
Voice is audible.
Audible.
Wir wollen, dass wir einfach eine kühlere Hallentemperatur haben, dass man zufriedene Mitarbeiter hat, das Arbeitsklima dadurch stärkt und natürlich auch die Maschinen. Wir fertigen im Tausendstelbereich. Da ist es eben ganz wichtig, dass die Temperatur eine Konstante aufweist und das zusammen ergibt dann natürlich die beste Qualität und wir streben alle nach bester Qualität. Also war das eigentlich auch unsere Entscheidung, dass wir uns für Infranorm und das Kühlsystem mit der adiabaten Kühlung entschieden haben. Die Vorteile waren einfach einmal die Wirtschaftlichkeit. Dann war einfach auch das der Vorteil, dass es keine Klimaanlage ist mit trockener Luft, sondern einfach auch eine allgemeine angenehme Kühlung. Und dass man wieder im Bereich die Temperatur auf einem gewissen Toleranzfeld halten kann. Das heißt in 2 Grad, dass man da konstant bleibt, dass man die Schwankungen einfach vermeidet. Auf die Mitarbeiter einfach, sie haben ein angenehmes Klima, sie können von der Früh bis auf die Nacht, wurscht zu was für einer Tageszeit, bei dieselben Temperaturen arbeiten, was natürlich sehr angenehm ist und eine gute Auswirkung auch hat auf die Konzentration, auf die Müdigkeit, dass man das einfach auch glättet und bestmögliche Qualität wieder rausbringt.
Thank you, Bhavanaji.
Yeah,
That's perfect. My apologies to the audiences because somewhere the subtitles when the gentleman was speaking, the client was speaking, his language was translated in English and was coming as subtitled at the bottom. But I think because of the IT tools and issues, we are not able to see the subtitles and we can't make out what he's saying. So the other video will have the same issue. So let's keep it aside. So, but my website, which is oxy-com.com, is a wealth of information. I am devout evaporative cooling man for 2 decades, but I had the kind of amount of informations in Oxycom we have gathered and put it in the public domain is colossal, is enormous. So if you are interested in evaporative cooling genuinely, please log in and see white papers. They're busting the myth related to evaporative cooling in every damn space. So it's got all the answers for a seeker of knowledge on evaporative cooling. So please log on to the website anytime and see it for yourself. So I will expect some increased website hits on Oxycom going forward. So any questions quickly if you can take in the next 5 minutes?
Yes,
So over to
there are a lot of questions.
please.
And first one is from Mr. Binoy Chaudhary. He is heading AEE Asia region here. And so we are glad to have him on our platform. And his question is, how the evaporative cooling will be applicable in hot and humid climate zones, such as in Kolkata?
Perfect. Thank you, Mr. Bina, for joining and raising this question. Very valid. Listen, I mean, I will put it this way. Humidity, it's like, evaporative cooling is again into the clean technology space, just like solar and wind. It's probably not a standalone solution for every location and every geography. Yes, in humid environment, the cooling effect will be low. But if you look at the applications, I remember in my career, one project in Kolkata I did for a flexible film printing company. They had no choice of going with air conditioning. Huge factory, huge machine load inside, so they can't do it. And the load inside with the machine was so high, it was all pure sensible load. Even with the outdoor air, and Kolkata in the summertime, you'll find the temperature hit 40 also at times. And when it is 40, you will not find the humidity is 80%. Typically, that's the weather pattern across the earth. When you are high temperature, your humidity is low. When you are lower temperature, they travel like this. The temperature is lowering, humidity is increasing, and the temperature goes up, humidity reduces. So we get some window to do some amount of cooling. If I can make that 40-degree air to 34, 32, 31 also, and bring it in the building, there will be some amount of relief cooling happening. In any case, those applications of industrial application need ventilation minimum. So instead of only ventilation, add bit of cooling with the evaporative means. So that much it can help, but it will not be a replacement or all prevailing solution. That's how I'll put it up. Hopefully I answered. Otherwise, you're most welcome to connect with any time going forward for a more detailed discussion on this.
Yeah, thank you. And another question is from Mr. R.L. Birla. It is not clear as what is the fluids being used for initial cooling of the outdoor air.
Perfect. It's water.
Water.
There's no other refrigerant in this. It's water. Water is cooled in the adiabatic stage in two, upper portion, lower portion. So if the outdoor temperature, whatever the wet bulb temperature is, outdoor wet bulb temperature is, the water in the two sections is cooled down to a level well below that, is pumped into a coil. The air passes, water picks up that temperature, it becomes very hot. It goes up onto the cooling tower, I mean the adiabatic section, initially cooled in the only pure adiabatic section, then followed by cooled with this air which is coming from the sensible stage and is brought down to a level less than outdoor or concurrent wet bulb temperature. I would request you to kindly sometimes log into my website. There is another animation and presentation describing these temperatures also. That will make it very clear to you, sir.
I have already typed the website address in the question answer box, so people can log in there. And now another question is from Mr. Kaurang Kumar Sharma. Can we use soft water? And his another question is, which method is preferable as scaling is scaling matter in this?
Your question is about the quality of water, how it is treated, if I understood correctly. Yes, scaling is a problem in evaporative cooling. The best way to handle this is to keep on, see, there are two ways. One is, you might have seen the large machines, some other brands, we have a huge water tank, some where 300, 400 liters of water or even more than that is stored. Is stored in the sense it's continuously going on, evaporation losses are being made up, but it's a huge sum. So the scaling is a big issue there. Smart solutions like in Oxcom, we have very narrow water tank or very narrow channel, so it doesn't retain too much of water. And we have, we can have a provision. I mean, it says optional thing with at least Oxfam, any other manufacturer also give. You can have salinity probes, the TDS sensors put inside the water. They keep checking the salinity of the water time to time and keep dumping that much of water to allow fresh water to come in and dilute the salt levels. So that's the breed of feature based on the TDS level of the sump water. That's one. The inlet water, which is makeup water, which is coming from outside, we don't need the RO water. We don't need desalinated water for that. We need the regular corporation supply water. Typically, to give a numbers, it's like, you can talk about TDS, which is in the range of 300 to 450 ppm is good enough, because that will have corresponding hardness level. Calcium, magnesium salt, which are the main culprit, will be under 100. So that is a good quality water to be used in evaporative cooling units. Not this, but any other brand, any kind of evaporative cooling.
Okay. Hope that answers your question, Mr. Karan Kumar. And another question is from Partha Kundu, who is a regular attendee of AEE webinar series. And his question is, how is Oxycom product different from HMX? I think that's...
Thank you, Parth. Thank you, Parth, for asking me this question. Had you asked this question to me 4 months back, my answer would have been quite different. I will say every product has its own unique, every brand and their configuration, unique positioning according to the application. HMX is a brand which probably nobody else than me knows better than that. I have spent 15 years there. So yes, they have a unique technology for themselves, which is good. Oxycom has its own. The main difference is the way they do indirect evaporative cooling. Oxycom uses the coil to do the first stage of indirect evaporative cooling, followed by the adiabatic. And then second major difference is Oxycom has got a unique heat exchanger for adiabatic cooling, which is a patented design. So like HMX has indirect cooling heat exchanger called DAMA, which is their patented design. Oxycom has OxyWeb, which is a replacement of cell deck pad. And that's a unique thing. Sometimes log into the website and explore for yourself. Inorganic material, longer life, cleanable, totally hygiene certified. I mean, it's a totally bacteria proof. So that's a different thing altogether. So both have their unique, features and characteristics. So that's it. That's how I can answer this.
And Mr. Jayesh Thakkar is appreciating your webinar.
Thank you, Jayesh ji.
Very impressive.
Yeah. That's what as a speaker we expect at the end of the session. That people should like. That's good enough.
Yes, it was very much interesting. Yeah. And now the next question.
Yeah. I answered that, Bhavna ji. I am looking at this question from Mr. Gadre.
Okay.
Yeah. So first stage, the first stage cooling, Oxycom we use coil, and as somebody said, HMX they use cross flow air to air heat exchanger. Many other manufacturers also use heat exchanger. Some people use coil. It's debatable in terms of efficiency, in terms of everything, which one can get into the micro detailing of that in a separate session. But yes, either way it can be done. And how can we develop it for the comfort application like domestic and commercial? That's a big challenge for the industry in general, the evaporative cooling industry in general, are ISHRAE two-stage manufacturers worldwide. Miniaturizing it is quite a challenge. Commercial, I think Oxycom has done it. If you look at simple 8,000 CFM unit, had it been from others, it will be probably a very lengthy, long, and maybe weighing around 2,000, 2,500 kgs. Compared to that, Oxycom unit is having a very small footprint, around 1.8 by 1.8. That's the kind of dimensions they will have, and weight is less than 500 kgs. So yes, it's an attempt towards that, four-side section and all. But going to the domestic level is quite a challenge, which is being worked out. It will be too early for me to jump the gun. Work is happening in that field. Yes, manufacturing my product in India may reduce carbon footprint. Probably, future will decide. It depends on the kind of response I get in the initial level, and then based on that, we'll probably do it. Okay, maximum and minimum enthalpy drop in two-stage evaporative cooling. Bhavna ji, I will share this presentation with you, which you can probably host it at some cloud or something. The people can see. So the answer to this question from Mr.
Normally, what we do is we post this complete recording on our LinkedIn page, so people can go there and refer to that.
Wonderful. So, Nehalji, to answer your question, what is the maximum minimum percentage of enthalpy drop in two-stage evaporative cooling? If you have seen the presentation, I had talked about pre-cooling of fresh air, FAHU retrofit application. There you will see I had talked about peak time reduction in the cooling loads of the fresh air. So you'll see your answer there for at least the 10 cities that we have talked about. Going beyond that, any specific location you have in mind, talk to me or just write to me and I'll be able to give you exact analysis for your location. What is the cost economics of adiabatic cooler against evaporative cooling tower in India? They are two different things. Adiabatic cooler, we are talking about, okay, the water cooled versus the air cooled. See, listen, if you are adopting for the greenfield project, somebody decides to go with the water cooled chiller, the first cost permits, that's the best answer. If not, if you have existing stock of air cooled chiller or you are installing an air cooled chiller today to save on your first cost and later on see what can be done, then the adiabatic pre-cooling comes in the play. So that's how it is. So there is no comparison. Cooling tower are used for the water cooled chillers. So there your capital investment is different. So that's how I can answer, like, the solution of pre-cooling of chiller, adiabatic pre-cooling of chiller is for existing stock of air cooled chiller, as well as the new project where probably you want to look at some amount of cost saving. You do not want to have big cooling tower lying somewhere. You don't have space for that. You don't have provisions to draw the water pipeline right from the cooling tower to the condenser and all. So that is where this becomes a fit for it. Yes, there will be some cost saving if you go with pre-cooling of this thing, but the efficiency will not be at par with the water cooled chiller. Let me put this caveat there. Oh, yes, Mr. Rahul Bansal. Can existing AHU? Absolutely. The existing FAHU, the fresh air handling units, can be easily retrofitted with the two-stage evaporative cooling unit to reduce the load of fresh air and have an annual saving as well as the peak time reduction of the tonnage requirement. Can two-stage be retrofitted? Yeah, some people are doing it. Some people are doing it. Probably we don't do it at Oxycom, but it can be done. But if you have, suppose, a AHU, you can top it up. I mean, you can top it up maybe Oxycom units behind it, and in the downstream of it, you will have your existing AHUs or existing evaporative cooling units. What about maintenance? Big question. Answer is bit long, but in Oxycom it's relatively much easier. And the best part is, as a responsible company, we take care of putting everything on internet. You don't have to ask for this. You just log into the website. You can find the O&M manual. You can find preventive maintenance guidelines. Everything is provided there, so it's available. Please write to me. I will be able to send you O&M manual copy itself, because that's in public domain. It's not that it's specific to the company. So but I can only tell you it's much lower than any other competing two stages or the other conventional air conditioning system. Oh, there is a Taporan website. It should be oxy-com.com. Thank you for pointing it out, JSG. Thank you so much for pointing it out.
I
Yes.
have typed it again. There was a mistake.
Okay. Perfect. So maintenance, Mr. Syed, thank you for putting this question. I think I just tried to answer it earlier. Water quality level also I talked about, and salt content, and you use evaporative cooling, whichever brand. My recommendation and suggestion as a person from evaporative cooling fraternity, you spend some money on installing a kind of auto bleed feature, which is based on the salinity probes and dumping the water. So that's a good thing to have the longer life of the unit and avoid the frequent failure of joking of pump and then clogging of pads and everything. So you should have the the salinity probe based auto bleed feature as a part of unit. It can be a top up thing also. If you already have some evaporative cooling units, you can get it as an additional accessories for your system also. And cooling tower to cool water, no, it's built in. Everything is within this magic box of 1.8 by 1.8. Everything is inside. You don't have to provide water from cooling tower. You don't have to provide water from chiller. Everything is built into this. Just plug the main supply, water supply, and it's done. And you know the best part, I mean, there are a few things which I've seen a number of brands globally. I've worked for some of them. You know, this side, if you can see behind my picture, this is my unit. You see this panel, side panel? My complete control panel is housed inside. Complete control panel. It's not a separate entity. You have to bring in one wire, fix it. You have to bring in one pipe to connect water inlet and one pipe to connect drain. That's all, and mount it. You don't have to do any additional, site. Put a control panel, draw hundreds of wire, connect it. So installation is as easy as 4 hours. Installation is done for one unit, and you move on. So we don't have to, have cooling tower here. What is the kind of phase velocity of air that is permissible for this kind of unit? So you are talking of velocity inside the user's area, like what should the velocity on the person who is enjoying the cooling from evaporative cooling. So I would recommend it should be in the range of around it should be around 0.2 meter per second. That's the most optimal range to get the right comfort, perception and feeling. So sorry, I think this answer is already done.
Yeah, website issue is already here.
Yeah.
I'm extremely sorry for that. Yeah.
No, I think this is all, and we are already 17 minutes beyond my schedule. I don't want to eat into your valuable time. It's of course a Friday, so that it is comfortable. And gentlemen, please, and ladies, please feel free to write to me. My email ID will be there in the recording. So I'll be more than happy to share what all I know about evaporative cooling. Yes, I work for a company, but beyond that, I think I'm a servant of evaporative cooling. I had been individually pushing to promote the technology of two-stage when the people used to shoo me away from their doors, that they don't want to listen at some solution which is 2 times as expensive as normal evaporative cooling or air washers. They were happy with air washer. So I'm happy that there's been significant contribution from individually from me as well as many other industry peers to bring two-stage into the mainstream cooling for the industrial level and some niche commercial level. Even in the Gulf countries, I was able to do that. Saudi, Dubai, Oman, Qatar, Kuwait. So these are the places where everywhere I've been able to push it to some extent as in my individual capacity. I'm happy that if you all look at evaporative cooling more seriously, rather than worrying for saving it 2%, 3% here and there, look for the better gains, larger gains, 80%, talk 80%, 70%, not 10%, 5%. Thank you so much. Over to you, Bhavanaji.
Thank you so much, Sunil. And it was a wonderful presentation and very good to see your dedication to the field. I mean, developing it and providing solutions for a better and sustainable future. So, and we thank all the participants for attending this session. And like we are in the last month of this series, but definitely we are going to continue it next year also with a different format. So stay tuned to our further announcements and emails that you will receive from us. Thank you once again. Yeah. Thank you, Sunil.
Thank you so much, everybody. Thank you for joining. Bye-bye.
Bye.
Thank you, Bhavanaji. And
Thank you.
probably time for me to also.
There's been a lot of appreciations in terms of
Thank
images.
you so much, Manu.
I'll be
Thank
sharing
you so
all the
much.
details with you very soon. Thank you.
So nice of you for providing me this platform so I can talk about it. I'll be this week and I will be again out of India for almost a couple of weeks. But then if I receive any question on email or something, I should be able to answer wherever I am in the world. So that's not a problem.
Okay.
Thank you. I'll sign off then. Bye-bye. Bye.